Foreign Mathematics, Paper 1, Core Pure Mathematics, Advanced Subsidiary, 8FMO, Monday, 11 May 2020. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. The total mark for this paper is 80. Question number 1. A system of 3 equations is defined. And there you see the three set of 3 equations, where k is a positive constant. Given that there is no unique solution to all 3 equations, show that k equals to 2. And part B, using k is equals to 2, determine whether the 3 equations are consistent, justifying your answer. And part C, interpret the answers to part B geometrically. So to do question number 1, we're going to use these ideas I've put below. You can see the formula. If determinant of a matrix is 0, then M is a singular matrix. If the determinant is not 0, then M is a non-singular matrix. And then you find the determinant of a 3 by 3 matrix by reducing the 3 by 3 matrix determinant to a 2 by 2 matrix determinants using the formula. So we're going to use this formula at the bottom to find the determinant. And we would set the determinant equals to 0 and solve that equation. So what we want to do is to find the determinant of the matrix corresponding to the system of equations. And set determinant equals to 0, solve the 3-term quadratic to achieve, we'll get k equals to 2, k equals to minus 8, which we'll reject. And I'll show you how we do that. So we can write k, 3, minus 1. The number in front of minus z is minus 1. And we can write 3 minus 1, 1. And minus 16 minus k minus k. So we have here a 3 by 3 matrix, and we want to find the determinant. So we would reduce it to this 2 by 2 matrix determinant. So the k would come in front, and then we find when you put the k, I'll cross out those lines for the k, and we find the determinant for that matrix in the middle. When you put 3 there, we'll cross out that column 3, and we'll cross out that row 3, that row there, and we'll find the determinant for what is left. And when we use minus 1, we'll cross that out, and find the determinant for that. So we're following that formula written there neatly. So we put k first. You see the pink line k, and we'll find when we put k, it will be minus k times minus 1. It gives you k, and then minus k times minus 1 gives you minus k, but k minus minus k becomes k plus k. And you do the same. You put the minus 3. Don't forget it's minus here. That's where students make mistake. This point there is a minus. Can you see that? Don't forget that part. It's the minus. So you put minus 3, and then you have k times minus k minus k times 3 will give you minus 3k, and then 1 times minus 16 will give you minus 16. But when you minus 16, it becomes a plus 16. And you will put minus 1 because it is a plus, but because we have a minus 1, it becomes a minus. So when you put minus 1, you have to multiply minus k times 3, it gives you minus 3k. And minus 1 times minus 16, it gives you plus 16, but when you minus it, it will be minus 16 there. Now you remove the bracket. K times k is k squared. K times k is k squared. After you remove the bracket, you collect like terms. I've put the like terms in yellow and in blue color. So k squared in yellow, k squared plus k squared gives you 2k squared. And in blue color, 9k plus 3k, it gives you 12k. And then minus 48 plus 16 gives you minus 32. And you set this determinant equals to 0 and you solve it. You put it in your calculator, you get two answers. K is 2 and K is equals to minus 8. So you would make sure you say you reject the answer K equals to minus 8. Sometimes people will say you reject it by omission, by not writing it. But if you write it down, make sure you write reject this. And the QED means quod erat demonstratum, as required to show. That's what it means. So using K is equals to 2, determine whether the three equations are consistent and justify your answer. So this is what a system of linear equation is consistent if there is at least one set of values that satisfy all the equations simultaneously. Otherwise, it is inconsistent. So consistent if there will be a set of values that will satisfy all of them. So if I write the equations and we want to use K is equals to 2, it's told us that in the question, K is 2. So we substitute 2 for K. Wherever we see K, we put 2. Wherever we see K, we put 2. So we replace K with 2. So we have 2x. For K, there is 2. 2x plus 3y minus z equals to 3. 3x minus y plus z is equals to, for K, we put 2, so it'll be minus 2. So you have three equations, 1, 2, and 3. Now, to solve these equations, we can eliminate z to achieve two equations in x and y. So I'm going to use equations 1 and 2 to eliminate z to get an equation. And then after that, I will use equation 2 and 3 to eliminate z again to get another equation and see if those equations are consistent. So to eliminate z from equation 1 and 2, because z is minus z and plus z, that one is straightforward. I picked that first because it's easier. You just add them. When you add minus z plus z, z will become 0. So you add equation 1 and 2, 2x plus 3x is 5x. 3 plus minus y is 2y. Minus z plus z is 0, and 3 plus minus 2 is 1. So that's one of your equations. Now, what we want to do is we want to multiply equation 2 by 2, multiply equation 2 by 2, and then add to 3. That will eliminate z. So multiplying equation 2 times 2, we times by 2 there, times by 2, times by 2, times by 2. That will give us 6x minus 2y plus 2z equals to minus 4. And we add that to equation 3. So 6 plus minus 16 gives you minus 10x. Minus 2y plus minus 2y gives you minus 4y. 2z plus minus 2z gives you 0. So z is gone now. Minus 4 plus 2 gives you minus 2. So we have that equation now in only x and y. We've eliminated z. Z has disappeared. Now we want to get it to positive. So we times by minus 1. So this will become plus 10. Times minus 1, this will become plus 4. This will become plus 2. Now we got these two equations. I've called them 4 and 5. If you look at equation 4 and 5 carefully, you will notice that if you times equation 5 by 2, you will get equation 4. So if you take equation 4, multiply it by equation 4 is the same as multiplying equation 5 by 2. 2 times 5 is 10. 2 times 2 is 4. And 2 times 1 is 2. So that means the two equations are a linear multiple of each other. That means if you multiply one equation by 2, you get the other one. That's what called linear multiple of each other. So it shows that the equations are the same. Therefore, the equations are consistent. Consistent because they are the same. And one is a linear multiple of the other. And then for part C, interpret the answer to part B geometrically. The three planes, because those three things form planes, the three planes form a sheaf. And if you look on the diagram there, you can see the plane 1 in blue, plane 2 in green, plane 3 in the red or burgundy. So you can see the three planes. The planes form a sheaf. The system of equation is consistent. and has infinitely many solutions represented by the line of intersection of the three planes. So the three planes meet in a line. You can see the line there in the middle. So there's a lot of points of intersection. So it forms what they call a sheaf. And I've got here some ideas for you to learn so that you can see this type of questions. I've circled a sheaf there for you to see. And it says there how if I've highlighted in yellow, if the metric is singular, there are two possibilities. That means if the determinant is equal to 0, that means there are two possibilities. Either the system is consistent, like we've just shown, and has infinitely many solutions, or is inconsistent and has no solutions. And we've done this one. So you can read through that. It gives you all the different options and to learn more. Question number 2. Given that Z1 is equal to 2 plus 3i, and given the other part as well, where Z1 and Z2 are complex numbers, write Z1 in the form r bracket cos theta plus I sin theta. Give the exact value of r and give the value of theta in radians to 4 significant figures. Part B, find Z2, giving your answer in the form a plus ib, where a and b are integers. So I have put here some of the key ideas we need to do this question. So to find the angle, tan theta is y over x. I've ticked it in red there. If you're given z is x plus iy. That's one formula we're going to use. And I've ticked the other one for a complex number z equals to r and argument theta. The modulus argument form is z equals to r bracket cos theta plus I sin theta. We're going to use that. We're going to use z1 times z2 is the modulus of z1 times the modulus of z2. Argument of z1, z2 is argument of z1 plus argument of z2. So we're going to use those things I have ticked there in these questions. So for part A, z1 is given by 2 plus 3i. So we want to find the modulus of z1 is given by 2 squared plus 3 squared. Square root of that, it gives us square root of 13, and that's the answer. And I'm just using this idea. The formula is there. I've put the notes there for you to read and put it there for you to look at how we got it. And how do we find the argument? I've also put the notes there for you. The argument is using the tangent of theta is y over x. So read those notes and it tells you why I'm using this. So the argument of z and tangent of theta is 3 over 2, which is like the y divided by the x. The y divided by the x. So it's the argument of z, which is the angle, is inverse tangent of 3 over 2. And you put your calculator in radians. That will give you 0.9828 to 4 significant figure. Because that's what they want the answer as. 4 significant figure. That's how you do that first part. And then to write it in this form, I've just ticked the modulus argument form. So we know r is square root of 13. And we've got the angle is cos theta, the angle is 0.9828. So the modulus argument form, you put your r is square root of 13, cosine of the angle is 0.9828, and plus I sine the angle 0.9828. So I'll put some information for the modulus argument form down there for you to read and to understand it. For part B, it says find Z2, giving your answer in the form A plus IB, where A and B are integers. So we know Z1. We know the absolute value of Z1 times Z2, if you look on the top right, is 39 root 2. So what we want to do is to find the modulus of Z2, and then after that, we'll find the argument of Z2. So we know Z1 is square root of 13. So we sub that Z1 square root of 13 for Z1 there. So we've got square root of 13 for Z1. We sub in Z1, Z2, which is given to us. Follow this pink line, is 39 root 2. So to get Z2, we divide 39 root 2 divided by root 13. That gives you 3 root 26. So Z2 is 3 root 26. Now we want to find the argument of Z2. we use this formula. Argument of z1, z2 is equal to the argument of z1 plus the argument of z2. And they told us that the answer is pi over 4. So we substitute that pi over 4. So now to get argument of z2, we make z2 the argument of z2 the subject. So it's pi over 4 minus the argument of z1. So the argument of z2 is pi over 4 minus the argument of z1. So pi over 4 minus inverse tangent of 3 over 2, which we know is 0.9828. And when you subtract that, you get that answer. Now, to put it in that modulus argument form, is 3 root 26 bracket cosine of 0.1974 plus I sine of minus 0.1974. Don't forget the minus. Now, you can expand. Expand means remove the bracket. You multiply 3 root 26 times cosine of minus 0.1974. And if you put all the decimal places to get the exact answer, or to get more accurate answer, and then you expand, multiply the other side as well, you get z2 is 14.99 minus 3i, and 14.99 to round to integer, nearest integer is 15, because it says a plus ib, a and b are integers, so it's 15 minus 3i. And see there how I put it in the calculator when I'm expanding. Root of 3 root 26 times the cosine of that. After that, 3 root 26 times the sine of that. So you get those answers.